Hey everybody, I miss you all. I wish we were together. This is going to be lesson 9.3, the constant rate of change and slope. We've already done this, but it was kind of a mishmash of people being there and not being there, and it was just a crazy time. So I'm going to go over it one more time, and we're going to do some more problems with it. A couple of terms you need to know: rate of change, linear relationships, and constant rate of change. So the rate of change is just how much one thing changes as another thing changes. So in other words, if I have, I'm measuring how high the plants are growing with every milliliter of water. So with every milliliter of water that I put on the plants, I can measure the height. How high do the plants get? So that's giving me my rate of change. What we're looking for, though, in this chapter is more of a constant rate of change. So in other words, that every time my X changes a certain amount, my Y will change a certain amount too. In other words, it'll be constant. And this is called a linear relationship. Linear means that it's going to give you a straight line. We've seen a lot of graphs these past couple weeks that have shown kind of graphs like this, talking about the exponential rate. And this is not what we're doing. What we're doing is going to be more of a constant rate. In other words, as X changes one amount, Y will change a certain amount too. It's going to be a straight line. Linear relationships are known when you graph them, you have a straight line. So you know you have a straight line when you have a linear relationship. And let me show you an example of what a rate of change looks like. So here we have some information. We have find out that we have every hour we've plotted how far we've traveled. So first hour we went 30 miles, second hour we went a total of 60 miles, third we went 90 miles, and fourth we went 120 miles. And that's the total amount that they went in 4 hours. And so what we can do is we can see how often our X changes compared to our Y. Now remember, X is the thing that we can change. We get to manipulate how far it's going to go. And X is going to be, when you look at the number of hours, we get to decide how long we're going to be in the car. So here we changed a positive 1 hour. Here's a positive 1 hour. Here's a positive 1 hour. And then when I look down here on the Y, how was that affected by the hours that we were on the road? Here it was a plus 30. Here it was a plus 30. And here it was a plus 30. So it looks like my rate of change was 30 miles for every 1 hour. For every 1 hour, we went 30 miles. And notice that I put my Y over my X. That's how we're going to be doing rate of change. We're going to be putting the thing that I can't control over the thing that I can control. So I went 30 miles per 1 hour. If I had to plot this on this graph right here, this would be my X right here. This is my Y. These are number lines, right? Here's my 0, 0 at this point right here. I can do a 1, a 2, a 3, and a 4 right here. And here I'm going to count by, let's just count by 30 right here. So I've got 30, 60, 90, and 120. And you notice that when I plot this, I have a nice straight line. Nice straight line. And that means that it's a linear relationship. It means that I have a constant rate of change, that my Y, the number of miles, is going to vary the same amount for every unit that I have on my X. All right, so here I have two scenarios. I've got a case where I've got the number of days on my X-axis, so that's the thing that I'm controlling. And Y is money, so how much money do I have? And you'll notice on the green graph, the green line, as the days increase, my money increases. So maybe I'm putting money into a savings account. On the red line, you can see that as days increase, my money decreases. So maybe I'm spending all the money that I had, and that's causing everything to go down. So one way to find slope when you're given this kind of data is to look at rise over run. That's kind of the old way of saying slope is rise over run. And what they're talking about is they're saying the Y's over the X's. The Y's over the X's. And what we do is we actually use this particular equation right here. Slope equals y2 minus y1 over x2 minus x1. And I'm going to show you how to do that. So first of all, what you have to do is you have to find 2 points on your graph. Let's just do the green one first. So let me change, we'll do green right here. So the green graph right here, I'm going to find 2 points, and I want to make sure that they intersect the grid lines. So I'm going to choose 2 points that intersect, and it doesn't matter which two, you'll still get the same one. Let me just do this one right here, and that the ordered pair for that one would be a 2, 10. Does everybody see how I got that? I said 2 is the x, and 10 is going to be the y. And then I'm going to do the ordered pair for the next one, which is 4, 20. 4, 20. And then I'm going to label these. I'm going to say this is going to be x1, this is going to be y1, this is x2, and this is y2. And then I just plug it into my slope formula. y2 minus y1 over x2 minus x1. And when I plug it in, my y2 is a 20, my y1 is a 10, my x2 is 4, and my x1 is a 2. And then I do the math. 20 minus 10 is 10, and 4 minus 2 is 2. Simplify that, and I have 5. So I am gaining $5 a day. So whatever I'm doing, I am increasing my worth by $5 a day, and that's my slope. That's going to be my slope. Okay, we can do the same thing on the red. And let's see what that's going to look like with red. I have to choose 2 points again that cross the grid marks. So I'll just choose the first 2 that I have there. First one is going to be a 1, 60. 1, 60. And then the next one I can choose is a 2, 50. 2, 50. Then I plug in again. I'm going to call this one x1, y1. I'll call this one x2, y2. And then I plug it into my slope formula. y2 minus y1 over x2 minus x1. And I plug it in. It's going to be 50 minus a 60 over 2 minus 1. And when I do that math, I end up getting a negative 10 over 1. And so that means I'm losing $10 a day. So whatever I'm doing, I'm losing $10 a day, and that's going to be my slope. That's my rate of change, is losing $10 a day. Okay, there's a couple more things I want to talk about that have to do with the type of line that you're going to have. Notice that this particular green, the green line right here, is going up. Every time I go up in my x, my y is also going up. That's a positive slope. And it's going to give me a positive, the slope will be positive. Slope is positive when you're going up like this. So when I have a graph where the slope is going positive, it's going to be like this. Slope is negative. Slope is negative when as x increases, y decreases. So that's going to be a negative slope, and it's decreasing. And then when the slope, if I happen to have a slope that looked like this, let's see, where every day I just have $40. Every day I just have $40. Notice that if I chose 2 points here, I would choose 1, 40 and 2, 40. And if I put that into my slope calculation, remember this is going to be x1, y1, x2, y2. Put it in, y2 minus y1 over x2 minus x1. And that gives me a 0 over 1, which is a 0. Horizontal lines like that have a slope of 0. So whenever you have something that gives you a horizontal line, that's going to be a slope of 0. And there's no change. There's no rate of change. There's no rate of change. My y didn't increase or decrease as x went on. So it has a slope of 0. Now, one thing to note is that if you have just use this one. If I have something like this, where I have a straight line down. Let's look at this one right here. Now here, I've got 2 points. Let me look at my 2 points here. I've got a point here would be 8, 10. And then I have another one, 8, 20. 8, 20. And if I plug this into the slope calculator, I have slope equals to 20 minus 10 over 8 minus 8. And that's going to give me 10 over 0. And remember, only Chuck Norris can divide by 0. We can't do it. So this is considered undefined. This is considered an undefined slope. And if you ever divide by 0, it's not going to be anything. It's going to end up being undefined. So we'll end up stopping at that point.